awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Okay, so in this paper we have 8 questions and the total marks is 80 marks. Okay, question number 1. Okay, show that Ft equal to Mv minus Mu is dimensionally correct. Alright, in order to show an equation whether dimensionally correct or not, so we need to determine what is the dimension of left hand side. So let's say this is the left hand side. Okay, and this is right hand side. Okay, so this one is right hand side. Okay, so the first one we try to determine what is dimension for the left hand side first. Okay, so left hand side, so dimension dia apa? So you want to know what is dimension of force times T. Okay, so is equal to dimension force times T. So the formula for force, okay, formula for force is F equal to MA. Okay, so you can change F, dimension F. Kita belum tukar lagi dimension. Kita just tukar saja equation force is equal to mass times acceleration and then times T. So this is dimension for Ft sama dengan dimension of M, AT. And then what's dimension for mass? So this time we can convert dimension for mass.
Capital M, madam.
Capital M. Hafal tak ni dimension?
Ya.
Okay. So kalau you nak tulis, okay, bila kita nak tulis dimension mass, so mesti ada bracket ini. This means that dimension for mass and this is dimension of acceleration A and this is dimension of T. So bila kita dah tukar, dimension of mass is capital M. So means that kita buka lah bracket tadi. So dia akan jadi yang macam ini. Okay. And then acceleration. So dimension for the acceleration. So kalau kita dah hafal acceleration, dimension acceleration is equal to velocity over time. Okay, dimension dia. So kalau you dah ingat dimension of, kalau boleh acceleration punya dimension ni awak ingat lah. So dimension of velocity is LT. LT -1 and dimension of T is T. So dia akan jadi dimension of acceleration is equal to LT -2. So kita masukkan kat sini. So tadi kita ada dimension of mass and then LT -2 is dimension for the acceleration and the last one is dimension of time, iaitu capital T. Okay. So kalau kita susun semula ni, so dia akan jadi dimension of MLT over T squared. T -2 ni maksud dia over L over T squared. Kita combinekan semua. So mana yang kita boleh cancel out tu, kita cancel out lah. T, potong atas dan bawah. So finally, dimension of the left hand side iaitu dimension for F and T is MLT -1. Boleh faham tak yang ini? Ada soalan?
Madam, yang kedua tu kurungan tu tak yang macam square bracket.
Jangan. Ya, sebab apa? Ini kurungan biasa sebab kita dah tukar dah dimension. Maksud ini kurungan ini, bracket ini adalah dimension of M, dimension of A, dimension of T. So once you dah tukar, dimension of M is capital M, ini awak dah tukar, dimension of T is capital T, then the bracket of the square bracket here, then you change to bracket yang biasa ni.
Baik, madam.
Okay. Alright. And then we proceed to the right hand side. Okay. So right hand side, so you can see here we have a dimension okay, MV, okay, and dimension of MU. Okay, so untuk right hand side ni dia ada dua. 1, 2. Kali hijau ni. Okay, so kita boleh cuba buat lah. Kita buat yang right hand side yang pertama. Okay, so right hand side yang pertama, dimension of M equal to dimension of V. Awak tengok dekat sini, dia adalah operasi tolak. Okay, so this is tolak. So kalau dimension tolak ataupun tambah, ingat semula kalau you ada dua macam tu, contohlah akhir sekali you dapat dimension of T tambah dimension of T. Maknanya dia tak boleh jadi 2T. Tak boleh. Dimension T tambah T is actually equal to T. Dimension LT tambah dimension LT is equal to LT. Dimension squared minus ML squared is equal to ML squared. Boleh So bila ada equation yang tambah ataupun tolak ni, dimension yang ini dia mesti sama. Jadi kita ada MV dengan MU. So you must show that dimension of MV, okay, dengan MU tu dia mesti sama lah. Sebab itu kita mulakan yang pertama dulu. The blue color first. Dimension of M times dimension of V. So that's mean dimension M is capital M. Okay. And then dimension of V is LT. Tulis terus pun boleh. LT negative 1. Okay. And then you can see here for the second right hand side. Okay. So the dimension, the green color here, dimension of M times dimension of initial velocity. So dia akan sama. So for the right hand side, kita kena pastikan dimension ini dengan ini sama. So baru kita boleh kata therefore, okay, dimension for the right hand side, dimension of M is equal, dimension of M times V is equal to dimension of M and U, where it is equal to MLT negative 1. So based on this one, you can see here that dimension of the left hand side is equal to dimension of the right hand side. So since dimension of left hand side equal to the dimension, tulis sama-sama, dimension of right hand side. Okay, so the equation is dimensionally correct. Okay, kita show lah. So dia minta kita show. So kita dah showkan dekat sini. So prove that dimension of the left hand side is equal to dimension of the right hand side. Boleh?
Boleh.
Okay, next question number 2. Okay, so check, calculate the total distance. Okay, ada dua. Okay, you must try to understand and differentiate. What is total distance and what is total displacement? Okay, so in order to calculate the total distance and total displacement, okay, kedua-duanya kita kena kira area under the graph. Okay, you must calculate area under graph. Okay, but for total distance, okay, look at here. For total distance, okay, in your calculation, okay, we will ignore the negative sign. Okay, but for the total displacement, since displacement is the vector quantity, so we must consider, in your calculation, you must consider or include the negative sign. Okay, so this is very important. So for number 1, So as we want to calculate the total distance, so we need to calculate the area under the graph. So you can see this is the first area of the graph. So this is also the area under the graph. And this is the second part. Okay, this is also the area under the graph. So you can see here, for the yellow color, okay, the value of the velocity is negative. Alright. So in your calculation, so you must ignore the negative sign. Kenapa? Sebab distance is a scalar quantity. It's not a vector quantity. Okay, so for scalar quantity, we ignore the direction. So we just consider the speed. Okay, so kita ambil lah kat situ. Untuk area yang pertama, so 1 plus dengan 2. So for the area under the graph, so total distance is equal to area 1 plus area 2. Okay, so area 1, awak kira lah. Okay, half. Aku tak muat kat sini, saya letak kat sini. Half times 2 times 4. Boleh?
Ya, benar.
Okay, saya tak ambil negative 4. Okay, kita kalau seolah-olah you letak modulus dekat negative 4 tadi. Plus the trapezium shape half times, okay, the parallel side, this is 5, 10 minus 5, so this is 5, and this is 2, 10 minus 2, 8. 5 plus 8. Okay, so 5 plus 8 berapa?
13.
Berapa?
13.
Kan? So, and then tinggi dia 6 lah. So, the height is 6. So, what is the total distance?
43 meter.
Okay, betul. Okay, so this is the answer. And then for the second part, sama jugalah. Cuma this time, for the total displacement, see, okay, sama juga 1 plus 2. Okay. So, it's equal to half times 2 times negative 4. So, this time we have negative 4. Okay. Plus half times 13 times 6. Okay, 13 tadi 5 plus 8 lah. Sama trapezium. Cumanya kita ada kat sini, kita ada negative 4. For total displacement, distance tadi tak ada lah. So, jangan careless. And then the answer is 35 meter. Sama tak yang awak kira? Okay. And then dia kata answer for 1 and 2 are not the same. Give your reason. So you can see here, total distance and total displacement tak sama lah. Kenapa? Okay. So tadi saya ada sebut berkenaan dengan scalar and vector quantity. So in order to answer question number 3, so we can say that, okay, for question number 3, so you can state that distance is a scalar quantity. Sebab tu dia tak sama jawapannya dengan displacement. Okay, and displacement, okay, is a vector quantity. Okay, boleh So we settle that one. Alright, and then 2B, okay, 2B is projectile motion. Okay, so let's try question 2B. Okay, a stone is projected horizontally with a velocity of 300 meter per second from the top of a cliff 100 meter high. Okay, so projected horizontally, so means that the value of u given here is ux. Okay, and uy is equal to 0. Alright, so projected horizontally, so means that we have a cliff here. Okay, when the height of the cliff is 100 meter. And then here you have a stone, and then you want to project this object horizontally. So, U yang dia bagi itu adalah UX. Okay, ini konsep yang you kena faham di mana UY is equal to 0. Jadi kalau student dia tak tahu apa beza projected horizontally ataupun projected at certain angle, Kalau ada angle, baru you kena resolve. Sama ada angle dia macam ni ke. Okay. So kalau macam ni, angle kat sini. So maknanya UX dia U cos theta. UY adalah U sin theta. Ataupun macam ini ke bawah. Below horizontal x-axis. Sorry, below positive x-axis. So let's say this is the angle. U, so UX to the right. So U cos theta. But UY is downward, so negative U sin theta. Okay, so bila ada angle, then you kena resolve. Tapi bila projected horizontally, tak ada angle. Jadi student kena faham di mana U yang dia bagi adalah UX and UY is equal to 0. Okay, so projected and then projected horizontally and then finally the object, the stone will landing at this point for example. Okay, so kat hujung ni nanti dia mesti ada final velocity dan dia ada angle lah sebab dia sengit sikit. Okay, so dia kena kira. Kalau you nak kira V, ingat semula dia adalah Vx squared plus Vy squared. Macam tu. Okay. And then, bila dapat soalan macam ni, kalau object launch at the top of a building ataupun at any top of, for example, for the cliff here. Okay, for example, when the object is released from the top of a cliff here. So, dia daripada atas, dia jatuh, turun ke bawah. So, at this point, kita panggil dia adalah, SY dia adalah positif ataupun negatif. What is the value of SY? SY is the vertical displacement. If the stone is projected at this point, point A, and then the landing at point B. So, berapa dia punya vertical displacement?
Negative H.
Negative H. Betul Negative 100. Jadi student kena faham. Ini maklumat yang kita ada. Keluarkan semua information yang soalan bagi. So we have 300, 0 and negative 100. And now, if you want to calculate the horizontal distance, SY adalah vertical distance. SX adalah horizontal distance, UXT. Okay. So number 1. So let's read the question for number 1. Okay. So how long will it take for the stone to strike the ground? Okay, how long will it take for the stone to strike the ground? So we want to calculate what is the time taken. Okay, time taken. So kat sini kita boleh guna formula SY. Sebab apa kita guna formula SY? Sebab kita ada maklumat SY dan juga kita ada vertical velocity. Vertical initial velocity which is 0. Okay, so you can use this equation. Okay, so remember this equation, okay, is in your question paper, okay, in the list of the equations here. But the question given here is linear equation. Which one? This one. Okay, ni. S equal to ut plus half at squared. Okay, so since A for the free fall motion or projectile motion, A ini adalah negative 9.81. Okay, so dia akan jadi S equal to ut minus half gt squared, which is negative 9.81 tu kita dah letak dekat half tu. Jadi bila you substitute nilai ini, kalau awak hafal dah formula SY equal to ut minus half gt squared, bila you substitute ini jangan masukkan negatif lagi sekali. So terus saja G nanti you ganti 9.81 meter per second squared. Sebab kita dah ada negatif dah depan ni. Okay. Jangan careless dekat situ. Jangan equation awak dah negatif. Lepas tu G tu awak masukkan lagi sekali negatif. Okay. So salah nanti. So this one is 100. So U tadi UY kosong minus half 9.81 T squared. Okay. You try to settle. So the answer is equal to 4.52 second. Okay, so this is the answer. Okay, and then number 2, determine the final speed of the stone. So we want to calculate V. At point B, so saya dah kata tadi dekat point B, student kena faham kita nak guna formula ini. Vx squared plus Vy squared. Okay, plus Vy squared. Jadi awak tengok pada soalan dia sebut final speed. Okay, dia sebut speed. Okay, so bila speed dia adalah scalar quantity. Okay, scalar quantity, so tak perlu cari direction pun tak apa. Okay, maknanya dia tak ada markah untuk cari direction. Tapi kalau soalan minta kita determine the final velocity, okay, for example for the velocity, bila you jawab nanti you kena kira V untuk dia punya magnitude, and then you kena kira theta untuk dia punya direction. Tapi untuk soalan ini, markahnya diberi untuk awak kira magnitude saja. Kalau tak kira direction, tak apa. Tapi kalau dia minta velocity, awak tak kira direction, boleh jadi salah lah. Okay, so kat sini kita nak guna formula ni. And then student kena faham macam mana nak cari Vx. Vx is equal to?
UX.
Yes, Ux. Okay, which is 300. And then tak ada masalah lah. But Vy, we can use equation Uy minus Gt. Vy tadi dah ada, Uy tadi kosong. Time kita dah ada. And then you just substitute saja. Okay. So Vy nanti you akan dapat negative 44.29 meter per second. Okay. So negative ni kenapa negative? Because the direction of Vy here is downward direction. You can see here. Okay. And then you can substitute V, masukkan dah tadi tu. 300 squared plus Vy is negative 44.29 squared, jangan tertinggal. So jawapannya adalah 303 303.3 meter per second. Okay. So disebabkan dia kira speed, tak perlu kira direction. Tapi kalau kita nak revise how to calculate the direction theta, so inverse tangent Vy over Vx. Cuba Jana kirakan berapa dia punya angle ni. Okay, this one you can put my modulus 44.29. So Vx is 300. Berapa angle theta dia?
8.40.
8.40. Okay, degree. So means that 8.40 ni adalah dia punya direction dia lah, which is below positive x-axis. Ini tadi. Ini. Sekejap saya tunjuk. Okay. Sini. 8.4. Okay. Below positive x-axis. So this is positive x-axis. So below. Which is 8.4 degree. Okay. And then the last one. Calculate the distance travelled by the stone. So we want to calculate the distance travel. So distance travel tu maksudnya adalah. Apa maksudnya? Ini. Sx. The distance travel. Selain soalan kata horizontal displacement, dia nama lainnya ada juga sebagai distance travel. Okay. So iaitu Sx. Okay. So kita boleh kira teruslah yang tu. Okay. Sx is equal to Uxt. Okay. Ux is 300 and time is 4.52. So finally the answer is 1356 meter. Okay, so this is the answer. Boleh
Okay, madam.
Alright, good. Alright, next. Okay, so this one we finish. Alright, question number 3. So we have a ball with a mass of 600 gram. So make sure you take out all the information in kg for the mass. And then the velocity, the initial velocity, it's moving with a velocity of 18 meter per second. And then hits a wall and turns back with a velocity of 8, which is negative 8 meter per second. So negative means that it's moving in opposite direction. So let's say this is the wall. Okay, so initially the ball is moving in this direction and then dia akan return back lah. Macam tu. Sebab tu V dia akan negative. So if the impulsive force between the ball and the wall is 6,000. So bila berlaku contact kat sini tadi, ball dengan wall, so ada impulsive force F. Okay, is equal to 6,000 Newton. So find the impulse. Okay, so this is very easy. So if you refer in your list of formula here, so you can use equation number 6, okay, 5, 6, 7. Alright, where impulse is equal to change of momentum, where momentum is equal to mv, and impulse equal to F delta T. Okay, so kalau kita nak guna formula F delta T, kita tak boleh. Sebab kita tak ada time. Ini adalah the time of impact. Okay, ini tak ada. Kita tak ada. Soalan minta kita cari nanti. Okay, so means that we need to use another equation which is delta P. Okay, mv minus mu. So mv, okay, make sure v tu you kena ni lah. Mana tadi? V dia berapa? Mass dia berapa tadi? 0.6, right?
Ya.
Yeah. So V dia adalah negative 8 minus 18. Okay. Sekejap. Terbalik ni. U dia 18 Kan?
Ya.
Tapi yang dalam skema ni dia bagi U dia. Betul lah, U dia 18. Boleh lah, mana-mana pun boleh. Kenapa V minus U? V dia adalah 8, right? So berapa dapat jawapan dia?
Negative 15.6.
Betul
Ha.
Negative
15.6.
15.6. Unit jangan lupa Newton second. Okay. Unit dia adalah Newton second. Okay, for impulse. Alright, and then the time of ball wall contact, okay, ataupun the time of impact number 2. So we can use J equal to F delta T. Okay, so in order to calculate T, kita boleh ambil macam ni lah Kalau kita dapat tadi negatif, tengok kepada gambar rajah kita ni lah. So bila ball hit the wall, you can see that the impulsive force should be opposite direction. Impulsive force dia mesti ke sini lah, ke kiri, F. Okay, so that's why kalau you substitute negative 15.6 here, F based on our diagram is negative 600. Force adalah vector quantity. So in this case, so bila bola ini langgar dinding, okay, they hit the wall. So the impulsive force from the wall on the ball, okay, the impulsive force from the wall on the ball is 6,000, which is negative, direction dia ke kiri lah. Okay, and then you can find what is delta T. Alright, so the answer here is 0.0026 second. Sama tak dengan jawapan awak? Ataupun awak boleh tulis sebagai 2.6 millisecond. Ataupun nak tulis juga 2.6 times 10 power of negative 3 second. Pun boleh. So this is the answer. Okay, boleh Jana?
Ya, madam.
Alright. Next question B. Okay. A block is being pulled up a rough plane inclined at an angle of 22 degree to the horizontal as shown in figure 2. Okay. And the mass of the block is given and the tension in the rope is T. Okay, maknanya maknanya yang ni dia tak ada friction Oh ada. Dia bagi kat sini if kat bawah. Okay. So for the first one, we have tension, this one. Okay. And untuk soalan nombor 1 ni, oh sebab dia dah sebut ni rough plane. Rough plane means that ada friction. Okay, so maknanya ada friction. So bila you nak lukis free body diagram, okay, so saya besarkan sikitlah gambar ni. Okay, untuk macam ni lah. Okay, so this is the plane and make sure awak faham lah. So let's say this is the block. Sekejap Saya ingat pula. Tak apalah. Saya tulis kat sini. Okay. So akan ada yang ini yang parallel with the surface. Ini adalah surface of the inclined plane. The yellow color is x component ataupun x axis. So kalau kita nak lukis, parallel with the yellow line is x component. And then the one that is perpendicular with the yellow line should be y component. Mesti 90 degree to the surface. Okay. So this is 22 degree. So wake straightly downward. Macam mana awak nak tahu dia straightly downward ke tak masa lukis tu? Make sure line awak, pembaris awak ni awak letak betul-betul line tu W tu 90 degree. 90 degree dengan triangle inilah. This is the base of the inclined plane. This is the base of the inclined plane and the arrow of W mesti 90 degree. Okay? So, then this is 22 degree. Macam tu. Lepas tu mesti ada normal. Lepas tu mesti ada friction dan juga tension. Itu saja. Jadi bila dalam exam untuk soalan number 1, okay, so we want to draw the free body diagram. So make sure you jangan nilah rotate. Okay, you jangan rotate the axis. Okay, so for number 1 tu, okay, so dia akan jadi macam ini. You jangan rotate the axis. So dia akan jadi macam tu. So this is the answer for number 1. So kalau awak rotate, dia akan jadi salah lah. So make sure awak punya arrow betul. Okay, arrow mesti keluar daripada tengah tu lah. Daripada center here. Okay. So mesti semua ada. You ada T, arrow T mesti betul, friction and W. Okay. So student tanya saya W tu nak kena resolve ke tak? Tak perlu resolve lah untuk free body diagram. Tapi untuk you jawab soalan number 2, then you kena rotate the free body diagram untuk awak kira lebih mudah. Okay. And then W tu kena resolve. Wajib lah. Wajib untuk you resolve. It is compulsory to resolve any force that has the angle of theta. Okay. So untuk jadi soalan nombor 2 ni, sekejap. So kalau untuk soalan nombor 2 ni, kalau kita ada ni kan, kalau kita nak rotate, contoh kita letak sini, and then you nak buat calculation, alamak ini tak boleh rotate pula. Tak apalah. Jadi untuk soalan nombor 2, you want to find calculation. Okay, soalan number 2, find the acceleration of the block. So given that the coefficient of the plane, the coefficient of friction of the plane is 0.25, and then the tension is given 5.6 Newton. So we want to calculate the acceleration. Okay. So dia mudah sajalah. Boleh awak rotate macam tadi saya kata. Rotate. So you tahu bila you rotate free body diagram. So this is tension and silap. This is normal. This is tension. This is friction. And W awak. Bila kita rotate ni tadi. W kita kat sini. W. So this is the angle 22 degree. So you must resolve. Resolve tu kena betul lah siapa cos, siapa yang sin. So W ni adalah cos or sin?
Cos.
Cos. So mg cos 22. Wx, Wy. Wx dia adalah mg sin 22 degree. Okay. And then lukis sikit arrow. Acceleration akan ke sini. Dia akan bergerak ke sini. Kan dia tarik ke atas. So barulah you mula dengan you mula total Fx equal to MA. Kenapa total Fx equal to MA bukan total Fy? Sebab apa? Tengok balik free body diagram kita tadi lah.
Sebab objek tu bergerak dalam komponen X.
Kan? Okay. Tengok balik. Kenapa pula ni? Sekejap saya kena buka balik. So total Fy akan kosong. Jadi dua ni lah student kena faham. Fx, equation ni kena betul. Okay, bila kita tengok equation salah saja, semua tu akan salah lah. Macam tu. So, dia akan jadi T plus friction opposite direction mesti letak negatif. Ni jangan tinggalkan. So, T equal to mu N equal to MA. So, tension dia dah bagi. Okay, mu ada, acceleration nak cari, mass ada tapi normal force tak ada. So, tengok balik dalam free body diagram, kita tahu normal force dalam Y component. So, that we can calculate N plus negative WY equal to 0.
Untuk X
WY
tak
downward.
include yang WX ke?
Saya tertinggalkan. Okay, bagus. So, kita tertinggal padam yang ni salah. So, saya tertinggal. So, awak pun jangan careless tau. Okay, so awak alert lah. Friction tambah negatif WX. Betul lah tu. Maknanya awak dah ready. Awak dah nampak mana saya salah kan? So, mg sin 22 equal to MA. So, semua ni dah ada dah. Ni ada, tak ada, nak cari. So, kita nak cari normal force tu tak ada. Pergi dekat Y component yang warna hijau ni. Where N is equal to mg cos 22. Kalau saya kira dulu siap-siap. Berapa dapat mg tu? Berapa dapat N tu? 0.7. N dapat berapa? Kirakan, pastikan kalkulator dalam degree mode Sebab cos 22 tu 22 degree. So, berapa dapat normal force?
6.37.
Okay, Newton. Then you can substitute here. Normal force dah ada. So, bolehlah kira acceleration is equal to T, where T is 5.6 minus mu 0.25 times normal force minus mg 0.7 times 9.81 cos 22 degree over the mass 0.7. Okay, so tekan calculator. Dapat tak jawapan? 2.05 meter per second squared. Dapat tak?
Ya, madam.
Dapat tak, Jana?
Dapat, madam.
Okay, good. Okay, so finish that one. Alright, C. Okay, C pula. An empty leaf has a mass of 1,200 kg. It is supported by a steel cable attached to the roof. Find the tension in the leaf cable when the leaf accelerates upward at 1.5 meter per second. Okay, so this is the empty leaf. So here we have a cable and the acceleration upward is 1.5 meter per second squared. Okay, and the mass of the leaf is given. So we have the tension and then weight. Okay, so ini senang sajalah, satu markah saja. Okay, so total Fy equal to Ma. So tension minus plus negative W equal to Ma. So finally you can find tension Ma plus Mg. Mass 1,200, acceleration 1.5 plus 9.81. Okay, so dapat tak jawapannya? Berapa jawapannya? 1.36 exponent 4. Dapat tak? Newton. 1.36 exponent 4 Newton. 2 markah kat situ.
Dapat, madam.
Okay, very good. See you in the next session. Don't forget to like, share and subscribe channel Madam Fika Fiki. Jumpa lagi. Assalamualaikum dan selamat sejahtera.